Hey guys, welcome to our channel of Sciences and Mathematics. Today we're going to learn a concept in mathematics. Of course, this is basic mathematics, and that is the concept of converting the rational decimals to fractions and try to see the relationship between the two. Now, this one assists in trying to find out a convenient way of trying to solve some of the problems that we may encounter in mathematics. And we're going to use illustrations or a few examples in order to achieve this or demonstrate how we can be able to convert between the two. So welcome. So subject today we're going to have a topic in basic mathematics, and that is converting rational decimals to fractions. So converting rational decimals to fractions. So in our discussion about rational numbers, or the general concept of numbers, we talked about different categories of numbers in one of our videos concerning the topic of numbers. We talked about different types of numbers. We talked about rational numbers, and of course, in this case, there's a category of numbers that is known as irrational numbers, natural numbers, etc. So in this case, we are trying to see the relationship between decimal fractions and what we call rational numbers. Now, rational numbers is a set of numbers, or is a set of all numbers that can be written in the form of AB. So we can say rational numbers, this is a range of numbers, or just which we can denote as Q. It's a range of numbers that can be written. So my handwriting can be written in the form of A over B, where A and B are integers. So in our discussion about numbers, we discussed the concept of rational numbers, integers, natural numbers, etc. So in this case, this is a category of numbers, and we are trying to see the relationship between these rational numbers and the decimal fractions. Of course, we are going to see that in this condition, when we have this is a numerator and a denominator, but there's a condition which is given that b is not equals to 0 for basic reasons, of course, which we're going to discuss. Or whenever a number or a fraction is given as a number x over 0, that number cannot be defined. So that is where we have written, that's why we have written this condition that is here. So basically we can illustrate these decimal fractions as a over b, given this condition that we have stated. In decimal notations, they are recepting or terminating, for example. So these rational numbers that we have designated as Q, in decimal notations, they are recepting, or what we call terminating. And I'm going to give an example for that. For instance, if I write this numerical figure 3, this can be written as 3 over 1. Since a number over 1 is just maintains that value, so this is just similar to that one, or equal to that one. And suppose it is 1 over 3, then we're going to see that this one can be written in the form of 0.33. And if I give another common one, this one can be written as 0.5. So therefore, these ones can be regarded as rational fractions, or maybe rational decimals, or fractions which have been converted to rational decimals. Now we're going to just illustrate that by using an example. For instance, if we are requested to convert this particular number to a rational, or convert the rational decimal to a fraction, and that one there, this symbol means that this number is repeating, so therefore this implies 0.6666 to that continuation. So what we're going to do this in this case, of course, when we are being requested to convert that one to a fraction, we let the 0.6666, of course, be a number or be a letter y, giving it that representation. So therefore, y will be 0.6666, and we're going to apply the powers of 10 in order to try to manipulate this figure. So we shall have 10y will be equal to 6.6666. So this is just similar to this one, because if you divide this like a multiplication of a number by or a known figure by a scalar, if we do the same to both sides, then we're going to return the value for that number. So if we try to have find the difference between the two, this is going to be negative 9y equals negative 6. So those negatives cancel, and therefore we shall have y represented as 6/9. And this is going to give us 3 goes here 2, 3 goes here 3. So converting this one to a fraction, we're going to use this procedure. You let that repeating decimal be represented by a number, and then you use the powers of 10 to try and manipulate that figure to achieve the result. Now the second example is going to give us an approach that we're going to use in case maybe 2 or 3 numbers are repeating. And that approach is what we're going to use in order to solve subsequent ones. So if we are asked to convert 3.76, and this implies that the 76 are repeating, so we shall have, say, let y be 3.767676 etc. So therefore, since there are 2 decimals that are repeating, we'll have to use a power of 10 that is going to multiply those decimal fractions and bring them to the left side of the equation. So we shall have 100 y is equals, this is 376.7676 etc. So if we try to find the difference between the two, then we are going to bring this y to this side, so that we are able to make the number of decimal coincide. So we shall have 3.7676. So we find the difference between the two, and then we are going to have 99y is equals, this is 373.0. So therefore the value of y is equals 373/99. So we have converted that one to a decimal fraction. Of course, one has to confirm whether it is in its simplest form. And now there are others, of course, which are going to have a variation, in a sense that these numbers that are repeating do not follow one another consecutively. So we are going to have an example in order to illustrate the same for that. So suppose we are asked to convert 3.0507, whereby 5 and 7 are repeating. So we say let y be 3.0507, and for this we can find the number or the powers of 10 that we can be able to use in order to bring these repeating decimals to the left side. So we say this is 1, 2, 3, 4. So 10 to the power of 4 is 10,000. Y is equals, this is 3507.05707. So we will have this 3.0507 for the value of y. So if we try to find the difference between the two, we will have 9999y is equals 30504. I hope my subtraction is okay. So we are going to have y represented as 30504 over 9999. So this one we have converted it as well to a decimal fraction. So that's the approach that we're going to use in order to confirm some of, to convert some of these from, of course, rational decimals to fractions. And we're going to also to see that how we can be able to achieve that by the reverse, of course, by doing a simple operation of division. But for this case, this is the concept that we're going to use in case we are required to do an operation of the kind. And I ask us to maybe give other examples that we may find different or which require other rules applicable for them to be solved in our comment section. So for that case, this is it for today. Thank you. Bye. God bless you.